I'm going to talk about sound sensor today in this video, which is also known as clap switch. I found this topic quite interesting because I have learnt a lot preparing this video and hope you will also be satisfied after watching it. But for that, you have to watch this video till the end. This sensor is actually built very intelligently. It has only three major components: a microphone that converts sound signal into electrical signal and typically known as electrical transducer, a potentiometer, a dual comparator LM393. This sensor has 4 pins. 2 pins are dedicated for the supply voltage, other 2 pins provides electrical voice signals, one provides digital voice signal and the second pin provides the analog voice signal. We'll see this in detail later. Let's see how this sensor converts sound signal into electrical signals. Microphone of the sensor receives the voice signals and translates these signals into digital signal and analog signal. To get the digital signal feedback, potentiometer plays a major role. The potentiometer shall be adjusted to set the threshold that will be achieved by making noise. Otherwise, you will never get any digital pin response if the potentiometer is not adjusted properly. On the other hand, analog sound signal is the actual voltage signal that is proportional to the sound signal. One thing to keep in mind that there is no amplifier is used to amplify the sound signals. For that reason, a very small rise or fall in the voltage level could be witnessed. Let me show you the hardware setup. I have connected the sensor with the Arduino. You can see that the supply is connected from the Arduino to the sensor, and the analog pin A0 is connected to the A0 of the Arduino, and the pin 8 of the Arduino is connected with the T0, which is the digital output of the sensor. So on the sensor, we have a mic. This is the microphone that converts the sound signal into the electrical signal. Then we have a potentiometer that we can set sensitivity of this potentiometer. And then the third part is this dual comparator. This is LM393. These are three major components on the sensor. Now we jump over to the Arduino IDE and start writing the code. I have already prepared few lines of code. It includes the defines of used pins and declaration of used variables. These variables will save digital and analog feedback of the sensor. In the setup function, I have started the serial communication with baud rate of 12 and set the pin mode of all these pins. Let's jump over to the loop function and start writing the logic. In the first part, I will read digital feedback of the sound sensor. To read this feedback, I need to read digital output of the sensor. Then print the saved digital value to the serial communication. We'll analyze this value later. Let's start writing logic of clap switch. The idea is, if a clap is detected, then LED connected to pin 13 will get turned on for 1 second. I verify first if the digital output value is high. That will be the indication of clap, and also if the LED is switched off. If both conditions are true, then the LED will get turned on. Whenever LED gets turned on, it has to remain turned on for 1 second, and then it should get turned off. 1 second delay will be introduced by the delay API. That's it. Now compile the code and upload it to the Arduino. Now I'll open serial monitor and we can see that the digital feedback is not really readable. Let's open serial plotter. So now you see it is 0 all the time. And now it goes to 1, goes to 0, goes to 1, goes to 0. It is like this. So now the clap test. I'll make a clap test and see if the LED really gets turned on for 1 second. Yeah, it works really well, I would say. Let's analyze the sensor's analog data. But first we need to make some changes in the code. Let's write the code to read the analog value from the sensor. For that I have to use the variable to save the analog values and use analog read API to read the pin A0 of the Arduino. I'm going to write this to the serial communication, this red value, that's it. Let's compile it. Compilation is successful. Now upload it to the Arduino. Now I'll open the serial monitor. Yeah, of course. This is the value that I was expecting because we are providing around 5 volt to this sensor and we have set the potentiometer to almost the half of its value, which is around 2.5 volt, and this is exactly or more or less 2.5 volt this ADC value is representing. So to read it in a more senseful way, I'll open this serial plotter and these values are more readable. So you see that how we are getting the ADC value from the sensor, and if I make now some noise, how these values will get changed. The interesting fact about the analog value is if I reduce the potentiometer value, the base voltage value at the analog output increases. To its extreme left where resistance gets almost 0 ohm, 5 volt is available at the analog output and no change in voltage is to be seen with this adjustment. If I rotate the potentiometer to its right, then we will get almost no value at the analog output and making sound has no effect on the output value. For these reasons, potentiometer shall be adjusted in a way that the analog and digital sound values can be read in some sensible way. I hope you have learned something new from this video. If you like this video, don't forget to hit the like button and subscribe to my channel.